Good morning, everyone. I'm Vedika Guru, and with me is Om Thorat. And today we will be presenting on contiguous allocation, a simple and fast file storage method used in operating system. So we will explain how data is stored on disk using this method and discuss its work, example, and limitation. So let's start. So, we will start with the introduction to file allocation. So, when files are saved on a disk, the operating system divides the disk into fixed size block and assign these blocks to files. This is called file allocation. A good allocation method ensures efficient use of space and faster access. So, there are mainly three types of memory allocation or disk allocation. So first one is contiguous and second is linked and indexed allocation. In this presentation we will focus on contiguous allocation, which is the simplest and fastest one. So after this, what is contiguous allocation? In contiguous allocation, each file is stored in adjacent blocks, like you can see here. These are adjacent block in which the files are stored, process A, process B accordingly. This the directory keeps two details for every file, the starting block address and the file length. So, since the file is stored continuously, both sequential and direct access are very fast, as it's simple to manage but not flexible when files need to grow or when space becomes fragmented. So, this is all about contiguous allocation. So, the working mechanism of contiguous allocation. When a file is created, it means when we created a file, the OS searches for a large contiguous free space. The file is stored completely in that region only. The directory stores the start block and length. I will show you the example in next slide. So we will more clarify about that. So files are read sequentially from that start block. So, however, when files are deleted or added later, small empty gaps appear. This is fragmentation. In this diagram, you can see each file occupies a specific part of disk. This is disk, and if a file is removed, the empty space is left behind, making it hard to store new large file, because if new large file wants more space. So here only we have 14, 15, 16, and 17, this much of space only. But what if files need more blocks of the memory? So let's understand this with this diagram and all. Here the disk is divided into numbered blocks. Each file has starting block and then length, which tells how many blocks are used. Like in file A, start is 2 and length is 3. So the occupies blocks 2, 3 and 4. Likewise for file B, start is 9 and end is 5. So occupies block 9 to 13, 9, 10, 11, 12 and 13. Likewise for file C, start is 18 and length is 8. So in this contiguous manner, the files is stored in the disk. So the pink color shows file A storage, file B storage, and and this contains some empty blocks also. So you can see in the diagram that all files are stored next to each other with no gaps, 2, 3, 4 for file A. This allows fast access because the disk head moves smoothly across the block. But when a file is deleted, but when a file is deleted, a free space appears. Like if we delete a file A, So 2, 3 and 4, these memory blocks are free. And if a new file is larger, it may fit this cause fragmentation. So contiguous allocation is fast and simple, but it's not very flexible for expanding files. It means when we have large files, so it's not work properly. That was the working and example of contiguous allocation. Now my teammate Om Thorat will explain its advantages and limitations and also the conclusion. Thank you.
Thank you, Vedika. Here are the main advantage of the continuous allocation. First, access. Files are the stored continuously, so the both are sequentially and directly access are quick. Second, simple implementation. Only start blocks and the length are the stored. Third, low overhead. No pointers or index table are required. Fourth, predictable performance. Access time remaining consistent. Next, the basic for the static files work will be for data that does not change often like a mini system of files. Now let's look at the limitations. Cause is the external fragmentation when the file are deleted or new are added. File explanation is difficult if the no space exists to the it require uh, require compassion which take times hard to the estimate file size in advance or wrong estimate waste space not suitable for the file frequently changes in the size. So while it is a fast, it is a not ideally for the dynamic frequency updates file. Not suitable or not dynamic files are poor choice for the file that are frequently changed in a sizes. To conclude, continuous allocation is a simple and give high-speed access. It is a best and fixed size or read only a file such as a CD and system data. But it is a suffering and low of flexibility. That's why the modern systems are used to linked and allocation overcome this problem. Still, the continuous allocation it import the foundation for the understanding file storage method. Thank you.